to Alpha Centauri to get rid of the noise introduced in the radio wave communications. So it's, you know, it's pretty much how it sounds.
We're creating a lot of jobs.
We're creating a lot of jobs. We're creating a lot of wire. How we're getting the metal for this wire, I don't know.
I can tell you right now, this is worse than just free space. Do we need attenuation of signals in wire?
Well, it would have to have relays in it, or you know, some way to keep the signal going. But you know, we'll worry about that later. But so this does get rid of the noise issue. We're going to need some relays, and some of the downsides. Well, let's be honest, you're not going to be able to do this. It's really impossible. The amount of metal that you need to stretch from here to Alpha Centauri, it's 4.3 light years. I don't know how many meters that is, but it's a lot. So yeah, we'd have to mine a lot of asteroids, because if we mine the Earth, we'd probably run out of material.
Well, let's think about it this way. If we got every celestial body in our solar system and lined them up one by one by one, would it even reach Alpha Centauri?
Depends on how thin we stretched it. So, coming to our final project, Project Relay, which Larry talked about as well. So in order to deal with the noise that is introduced when communicating over such a large distance, we came up with the idea of splitting the actual job into smaller pieces done by communication buoys. So you basically send a signal, and a communication buoy would pick it up, error check it, make sure that everything was good, and then it would send it on again. So these would be scattered, some set distance. Larry talked about setting it up every 500 AU. It could be smaller if we had more relays. It would just introduce kind of more room for error, because each one would have to demodulate the system, then remodulate it. So, any questions?
This is. I'm Did anyone happen to look at my amazing equation for filtering these paths? So I need to set up the
Okay, go get up there.
But like,
Show your face on camera.
can you go to the drive quick? So it's gonna be, I think it should be in payload, because I think I just kind of jacked your folder and put it in there.
All right.
Yeah, Gaussian dispersion applied to acceleration gates for shit navigation.
Seems pretty intense.
Yeah, I know, right?
Not gonna lie.
Okay, so
Oh my goodness.
using various physics forms and things that probably aren't very good sources, I was able to take Gaussian dispersion models, which is what we use for plumes to figure out what the concentration of something's going to be downwind a certain amount of kilometers. And what I was able to do is take that to filter it for some type of maybe control system for figuring out where our ship is. So what it is it takes a circle with an X and a Y coordinate, and it effectively figures out some kind of drift based off of both the properties of the ship and the properties of any kind of orbit that would be around it that would be experimentally figured out. And basically what it does is it helps us guess the trajectory that it would be at some certain type of speed. And as you can see, at t almost instantaneous, you have kind of a wobble coming out of the gate. Imagine the y-axis being a gate, so you have a wobble. And then as it's going, you kind of end up having more of a curved path, and then the farther that it gets out, which would be T2 average, that's basically the more off you are. So just imagine that like the more it is away from the x-axis, that's the more off you are. So I didn't plug this in yet to anything other than a MATLAB script, but basically what it was is I was able to draw a line using an equation. Mostly the parabolic ones work mostly, but you can use the ones x3rd, whatever that is first also. And basically what it is I could type in an x and it will line up. It would take a certain number of these gates and it will line them up to that path for me. And it's actually pretty accurate. Some of them, I can get it to go right through the center of the path. But that's not what we need to do. What we need to do is be like, okay, well, it didn't exactly reach that one where we wanted it to, so say it's off by some x and some y. So I'll know, the other one will know how far it has to move to be close. And it's a filtering thing, so even though like you move it, it's still not gonna be right, but it just basically keeps happening over and over again. So what you're doing is, instead of breaking up to we have to go from here to Alpha Centauri, it's just a bunch of, hey, we just have to go from this gate to that gate. So it works out pretty well in the MATLAB thing. I mean, it's obviously not perfect, but it's kind of my baby. Like I love this problem. So
If these acceleration gates end up being feasible, like that would be really great.
well, I mean, this doesn't take into consideration energy or anything. This is just path.
I think one major concern is building the acceleration gates.
I will take that task upon
I
myself.
actually think that's a concern that power is.
Be my life's work.
I think that's less of a concern.
The power is the biggest.
Building it is.
If we just have like a system like what Damien's using for propulsion, we could just use that to move it into place and then use whatever we're using to generate power off of that to generate the power for these. So the way the acceleration gate would work is we'd have to charge capacitors and discharge it extremely quickly. So what we'd need is just a battery array that would then charge a capacitor bank, and then it would just unload all of its energy. So,
Have you thought about how much force that gravity acceleration causes on the ship?
well, we can adjust it so that it will apply enough force that it won't break the craft, but it'll still get it up to a pretty good speed.
Yeah, that Q factor is an experimentally determined property of the ship that takes velocity into account of the ship, because obviously if you're going through the gate faster, you're gonna have a lot less of a drift. And also one thing I forgot to point out is, you see how that U factor is under the Q? That's because that whole graph there does not take gravitational anything into account. Now if I just use an n-body system thing, and I just use G equals mass, radius, or distance between the two, all that's going to do on that graph is pull it either like up or down, and that's basically all that's saying is you're going to be this far off or that far off. So it's really not that complicated of a fix to just add gravity into there. I just haven't done it yet because I haven't found a way to just throw a planet into a MATLAB script.
And power needs are pretty much just determined by how many acceleration gates we actually have. The less acceleration, or the more acceleration gates, the less power we need, because we have more that can provide a force to the craft.
Energy becomes the limit.
Yeah, so we'd still need the same amount of energy, but it's the same thing with the relays. We can generate power in each thing instead of all at once.